Learn more on BBC Bitesize.
Have you ever wondered how some of our devices can charge so quickly? Understanding the characteristics of electrical components is crucial to design devices that can charge our phones safely and speedily.
Well, we can understand the behaviour of components through their current voltage, or IV, characteristics. These are usually displayed as a graph.
There are three components that we need to generate IV characteristics for. These are a resistor, a filament bulb, and a diode. For this experiment, you will need the following equipment. Please pause the video if you want to take a closer look. These components may get hot while you're using them, so switch off the circuit when not taking readings to avoid injury and limit the current to the lamp. First, we're going to build a circuit to test the resistor. We'll follow the circuit diagram carefully, starting from the positive side of the battery. Once complete, we'll add the voltmeter.
Okay, remember that an ammeter is always connected in series in a circuit. This measures the current. However, a voltmeter should always be connected in parallel because this measures the potential difference across the component being tested.
By changing the resistance of the variable resistor, we vary the potential difference supplied to our component. Let's start with a value of 0 ohms. We can then take our first voltmeter and ammeter readings, which we will add to our table of results.
We'll then alter our variable resistor setting 4 more times, which will give us 4 additional values of potential difference and current.
An IV characteristic curve should also include negative values. This is where the potential difference is applied to the components in the opposite direction. We just need to swap over the connections to the battery and then repeat the entire experiment.
We can now plot our IV characteristic graph. We're plotting potential difference on the x-axis and current on the y-axis. Finally, we can test our other components. Simply disconnect the resistor and replace with the next component to be tested.
So now we're going to test our final component, which is the diode.
Okay, but there are 2 things there.
Yes, so because of the diode, we need a protective resistor.
Okay.
So it's going to put that in place first. Also, because the current through this circuit is quite small, we're going to replace this ammeter with a more sensitive one.
Okay.
So take that one out.
Take that.
Yeah. Okay, there.
Okay.
And then now I'm going to replace the light bulb with the diode.
Okay.
We then repeat the steps we followed for the resistor.
Once we've collected the data for all 3 components, our IV characteristic graphs should appear as follows. A resistor gives a straight line graph that runs right through the origin, showing that the current is directly proportional to the potential difference.
Now, a filament bulb increases in resistance as the current increases. As the potential difference increases, the current does increase, but at an ever decreasing rate. Both of these components behave in the same way regardless of which way the current is flowing. However, a diode gives a very different IV characteristic, because when it's connected in the forward direction, a certain level of potential difference is required to cause a current to flow. Above this value, the resistance decreases significantly, so current increases rapidly with potential difference. However, when connected to a reverse potential difference, no current flows at all. The resistance is infinite in the reverse direction.
Circuit designers use IV characteristics to help select the most appropriate electrical component for when designing a circuit to, for instance, charge your mobile phone quickly and safely.
For in-depth GCSE resources and practice, visit BBC Bitesize now.